In this video, we're going to show that the limit as theta approaches 0 of sine theta divided by theta is equal to 1. Theta is just a variable that's often used with trigonometric functions. This is true for any variable, so limit x goes to 0, sine x divided by x also equals to 1, of course. To show this, we're going to need a little bit of review from trigonometry. So this is a sector of a circle. What is a sector? A sector, just imagine a circle is a pie, and we're cutting out a piece of a pie determined by angle theta. The area of such a sector is 1/2 times the radius squared times the angle measured in radians. So when theta is 2 pi, 2 pi times 1/2 is pi, and we get the familiar area of a circle, which is pi r squared. Now when theta approaches 0, it approaches 0 from two sides, either from the right when theta is positive, or from this side, from the left, when theta is negative. So we have to look at two cases. Let's say case 1, when theta is positive, and we're interested in theta being close to 0. So let's take theta to be less than 90 degrees, or pi over 2, bigger than 0. In case 2, again, we're interested in theta being close to 0. So let's take it to be greater than minus 90 degrees, which is minus pi over 2, and less than 0. We're going to look at case 1 first. So to do that, we're going to draw the following picture that will help us solve this problem. Picture is really very helpful here because it allows you to see what's going on, and much better than just using formulas. So let's look at the following. We're going to draw two sides of length 1. So this side is length 1, and this side here is also length 1. Let's call this point O. This point over here, the other end, call that A, and let's call this point right here B. First, let's form a sector like this, and this is our angle theta. So sector OAB, I think that's the notation for it. Sector OAB has area 1/2 times the radius, which is 1 squared, times theta, which is 1/2 theta. So the area of this sector, if the radius is 1, is 1/2 theta. Now let's form a triangle, and this is a triangle OAB. As you can see from this picture, the area of this triangle is less than the area of a sector. So we can write this down, that the area of triangle OAB is less than the area of a sector. We already know that that's 1/2 theta. So what is the area of this triangle OAB? I'm going to drop this perpendicular and call it little h. The area of triangle OAB is equal to 1/2 times base. The base is side OA, which is 1, times the height, which is what I call h. But h is not the variable we want to work with because we're interested in variable theta. If we look closer at this, and let me call this point right here D. In triangle ODB, it's a right triangle, so the opposite side is h. The hypotenuse is 1, so sine of theta is opposite over the hypotenuse. Since the hypotenuse is 1, h equals to sine of theta. So the height that we're interested in as function of theta is just sine of theta. And since the area of OAB is less than the area of a sector, we know that 1/2 sine theta is less than 1/2 theta. We have that so far. Let's form another triangle. So I'm going to extend this up here, call this point C, and drop this down to A. So let's look at triangle OAC. OAC is a right triangle, and let me call this side capital H. Its area is 1/2 times the base. The base is still side OA, which is 1, times the height, which is capital H. So I want to find capital H in terms of theta as well. So from this being a right triangle, opposite, which is h, divided by adjacent, which is 1, equals to tangent of theta. So tan of theta is equal to a capital H. So here's what we have so far. We have triangle OAB, okay, its area is less than the area of the sector OAB, and that in turn is less than the area of triangle OAC. Now this is 1/2 sine theta less than 1/2 theta less than 1/2 tan theta. Let's multiply through by 2 or divide by 1/2. That means sine theta is less than theta and less than tangent of theta. Now that's when, remember, theta is less than pi over 2 and is greater than 0. So everything here is positive. Sine is positive, theta is positive, and tangent is positive. We're going to divide by sine. Remember that sine of theta over cosine of theta is tan theta. So when I take tangent of theta and divide it by sine theta, the sines cancel. We get 1 divided by cosine of theta. So dividing this inequality by sine theta gives us a new inequality. 1 less than theta over sine theta less than 1 over cosine theta. Let's flip everything. Remember, when you do, when these are positive numbers, inequality gets reversed. So 1 is greater than sine theta over theta, and that in turn is greater than cosine of theta. And here's the quantity we're interested in, the function we're interested in. Let's rewrite this as cosine of theta less than sine theta over theta, which in turn is less than 1. Let's apply limit to all sides. Limit theta approaches 0 of cosine theta is less than or equal to limit as theta approaches 0 of sine theta over theta, and that's less than or equal to the limit as theta approaches 0 of 1. Well, plugging in 0 into cosine of theta gives us 1, and limit as theta goes to 0 of 1 is 1, so we have 1 less than or equal to limit as theta goes to 0 of sine theta divided by theta less than or equal to 1. By squeeze theorem, we conclude the limit as theta goes to 0 of sine theta over theta equals to 1. Now this is just for case 1 only, when theta is positive. Let's look at case 2. Case 2 says that theta is greater than negative pi over 2 and less than 0. So it's theta is a negative value. Let's multiply everything by -1. That gives us minus theta greater than 0 and less than pi over 2. So minus theta is between 0 and pi over 2. It's the same situation that we had before. Therefore, cosine of minus theta is less than sine of minus theta over minus theta and less than 1. But cosine of minus theta is cosine of theta. Remember, theta is negative. That's we're in case 2. So cosine of theta is still less than sine theta over theta, and that's still less than 1. Applying squeeze theorem again, exactly the same thing. We end up case 2, limit theta goes to 0, sine theta over theta equals 1. And we've proven that the limit exists because the right-handed limit, the left-handed limit, they both lead to the same place. That is, the limit as theta is equal to the limit of theta going to 0, sine theta over theta equals to 1. So this is a very, very important limit. This is the proof of it. In some of your courses, if you're taking this, some instructors may emphasize this proof, some may not, but it's always better to